Please share this video and the others that you are watching in my channel. Share them to your friends, your WhatsApp group. You just copy the link there, share, you go to share, copy the link, and then share to your friends, share to groups. That is the only way you can assist me, kwa sababu najua uwezi nitupea pesa, si ndio? Sasa unisaidie ku share these links, share the videos to your WhatsApp groups. Hivyo utakuwa umenisaidia. A and B are 2 points on the Earth's surface and on latitude 40 degrees north. The 2 points are on the longitude 50 west and 130 east respectively. Calculate the distance from A to B along a parallel of latitude in kilometers. So first we need to sketch. That's our sketch. And then this is the equator, 0 degrees, and this is the prime meridian, 0 degrees, right? So we want to locate the latitude where the A and the P lie is 40. So this is 0, 20 somewhere there. So here, somewhere there we have 40 degrees north. So, and then we are told that the 2 points are on the longitude 50 west. So from here, this is the prime meridian, so to the left is west. So 50 could be somewhere here. So here is point A. And then B is 150 on the same latitude. So 100 could be somewhere there on the other side, like this. Somewhere here. So this is the point B. So now we have our point A and B. You can clearly see that A is on 40 north, 50 west, that is A, and the B is 40 north, 130 east. We have done that. So calculate the distance AB along the parallel. Remember, this is the equator and it is parallel with this. So we are calculating the distance along the small circle. So this is the small circle here. So we are calculating this here, where this is going to be the alpha. So how do we calculate the distance? First we need to get the angle difference. We have said this one is a small, lazima ujue kwamba hii ni small circle. Kwa nini inaitwa small circle? Iko kwa 40 north. 40 north, we have discussed that in the previous video. Kwa hivyo, so let us see angle difference. Angle difference is 50 west and 130. So kutoka hapa mpaka ufike 0 is 50. From 0 to 130, so we add, that is 130 plus 50. So our angle is 180 degrees. That is angle difference. So distance equal to is given by alpha over 360 2 pi r cos theta. Kwa sababu this one is a small circle. If it is a small circle, this is how we get the radius of that small circle. Kama hujajua, kuna videos nimefanya za latitude, tafadhali zipitie. So now let us, the alpha is this one, and this theta is the latitude angle. Latitude angle. So our latitude here is 40, therefore the angle theta is 40. So which is now 180 over 360 times 2 times 22 over 7 times 6, 370 cos 40. Cos 40. This one will give us 15 kilometers, and we have calculated the distance parallel latitude because it's on the latitude from A to B on this latitude. This is how we do it. So kitu ya kwanza ni kutambua whether point A, B lies on the small circle or great circle. So we have seen it's a small circle. Number B, the shortest distance from A to B along a great circle in kilometers. So now we are calculating the distance between A and B, but this time round along a great circle. Tunajua vizuri that a great circle O inapita kwa longitude. So we are going to calculate the distance AB through A going this way. So if it will go like that, we will go along the great circle. And if it is along the great circle, then the center of this great circle, the center here is going to be at this point because that's a great circle. So we are going to have this thing here. So our theta is going to be here. So let us now extract this one. So we are going to have this one, this, and then we have the equator, 0, and then we have this. So this time around we are here AB. We are not going to get this distance AB. We are going to get AB through A this way. So the angle is going to be this one, right? But we know that the latitude here, the angle latitude here is 40, right? We know the angle here is 40. So remember, this is parallel and they are parallel lines. If they are parallel, this one is a transversal, right? So it means that the angle here, it will repeat the angle here. The angle here, 40, will repeat the angle here, 40. Right? So this is a straight line, it forms 180. Therefore, the angle at the metro is 180 minus 80, which is equal to 100. So our theta now is going to be 100 degrees. Right? I hope umeelewa kenye nimesema. Now our distance is going to be given by theta over 360 to pi r, because it is along the great circle, So this one will be 100 divided by 360 times 2 times 22 over 7 times radius 6370, and that one will give us 11122.2 kilometers. And you are done. Find the distance between 2 points A, 50 north degrees and 20 degrees east, 50 degrees north, 50 degrees east. So first we in kilometers and then in nautical miles. So let us go straight away. Let us first see, is this a great circle or a small circle? So the good thing you must do is that you have to sketch. Let us sketch first. So this is the equator, and this is the green meridian 0, Greenwich meridian. So A is on 50 north. So 50 north could be somewhere there, 50 degrees north. And then we have 20 east. This is 0, so 20 east could be somewhere here. So this one is 20 degrees east. And then, so remember this now is going to be our point A. And then we have B, let me call this one B. 50 north, the same latitude, 50 east. So 50 east could be somewhere here. So this is 50 degrees east. So their center is going to be here. So their center is there. So the angle they form at the center, at their center up there, is that one. Right? So first we get the angle difference. Angle difference is 50 minus 20 because they are on the same side, which is going to be 30 degrees. Because we realized it is a small circle because it equals 50 degrees north, that's a small circle. Therefore, we know the formula. So that is our alpha is 30 over 360 times 2 times 22/7 times radius 6370, but we were given radius 64, so we use that 6400 cos latitude, which is 50. So you use the take radius to be the one you have been provided is the one you use. So finally this one is going to give us 2154.87 kilometers. So that is the distance AB, A and B. Then Roman 2 in nautical miles. How do we get a radius or the distance a small circle using nautical miles? We know the formula is 60 times alpha times cos theta. 60 is a constant, 60 times alpha, our alpha is 30, cos times cos theta, which is the latitude angle, which is 50, cos 50. And this one will give us 157.02 nautical miles. The position of two towns A and B are 50 degrees north, 45 degrees west, and 50 degrees north, k degrees W or west, respectively. It takes a plane 5 hours to travel from A to B at an average speed of 800 knots. The same plane takes 1.5 hours to travel from B to another town C at the same average speed, comma, full stop. Given that C is to the north of B, calculate to the nearest degree the value of K. So now we want to calculate the value of K. Very important. So let us sketch. This is the equator. This is the Greenwich meridian, which is 0. So we want to locate A. A is 50 north. 50 north is there. 50 degrees north. And then 45 west. 45 west could be somewhere there. Somewhere there. So here is our point A. Our point B is the same latitude but to the west again. So it could be somewhere there. We guess it could be somewhere there. We don't know where it is. So let me say this one is part B. It is on the same latitude but we don't know the longitude where it is. So that's what we are looking for. So here is K. The latitude is K. The longitude, sorry, not the longitude. This longitude is K degrees west, this one. So, but we have been given the distance, we have been given the speed and the hour. So how do we get the distance? Distance is equal to speed times time. So distance is equal to, we're going to be 800 times 5. And this one gives us 4,000 nautical miles. So we have been given distance nautical mile. Ask yourself, is this a small circle or a great circle? Is it a small circle or a great circle? It is a small circle. So we know how to get the distance of a small circle in nautical miles. That is 60 times this change cos theta, where theta is the latitude. So what we don't have here is the change. We don't have that change. That's what we are looking for. So this one is giving us the distance. Distance is equal to this, but this is 4,000 is equal to 60 cos theta times alpha. So alpha is going to be 4,000 divided by 60 times cos. The alpha is 50. So alpha is going to be 103.7. So how do we get K? So K minus 45, because they are on the same side, west to west. This is west and this one is west. The angle difference is K minus 45, and this one will give us 103.7 degrees. So we like terms together. This one is going to be this side. So K is going to be 45 plus 103 148.7. K is equal to 148.7 degrees. But of course, west. Degrees west. Part B, the latitude is C. So the same airplane has gone to C through to another, from B to another town C on the same average speed. The most important information is that C is on the north of B. So if B is here, then C, it could be there, the north. So it is somewhere there. So this one is C. Here we have C on the same. So you can see clearly that B and C, they are on the same longitude, but different latitude. Therefore, it is on the great circle. So their center comes here. Their center comes here, and we are going to look for this theta, that is the angle difference. I hope you have seen that. So let us now see how to, we have now the distance, because they are going on the same speed, therefore we can get the distance. That is Roman 2. Distance is equal to speed times time. Our speed is 800 times time is 1.5, that is 1.5 hours. And this one gives us 1200 nautical miles. But we know this one is on the great circle, right? How do we get the distance in nautical miles? Distance in nautical mile on a great circle is simply 60 times theta. So we don't have theta, it is the one we are looking for. So 60 times theta is equal to 1200 nautical miles. So divided by 60, therefore theta equal to, this is 20, equal to 20 degrees. Theta is equal to 20 degrees. So C is on X degrees north, 148 degrees, 0.7 degrees west. That is where we have C, right? So we want to get this C. What was C? Because the angle difference is this after subtraction. So it means X, this one, minus that of B. So let me write B is, we had B here. B is on 50 north, 148.7. So you see they're on the same longitude, so we don't mind that. So this X minus 50 will give us what? 20, the angle difference. Therefore, X is equal to 20 plus 50. And that X is equal to 70. So C is 17 degrees north, 148.7 degrees west. That is C. So C is 70 degrees north, the latitude is 70. An aircraft took off from a point P, 60 south, 76 west, and flew due north to a point Q. The distance between P and Q is 5,400 nautical miles. Determine the position of Q. Determine the position of Q. So first let us sketch. So this point P is 65 south. So 65 south, remember this is 0 degrees equator. This is another 0 here. So 60 south could be somewhere there. This one is 60 degrees south. And 76 west. 76 west, this is 0. So 76 west could be somewhere there. So this one here is our point P. Right? So it flew north. So it flew north on the same longitude. It flew north of this to a point Q. So it went to a point Q. We don't know where Q is. Let me just guess that it arrived at that point. We don't know, but we just sketch like that. So then determine the point of Q. Let me call this point here Q. So before we finish, let me show you something. This is latitude here, which is on the north, is parallel to this one. And if they are parallel, if we draw a transversal here, like this, it means this angle here will be the same angle at the center of the earth. Very important for you to know. If I draw a transversal, this is a parallel lines and these are parallel. So from this point and this point, I draw a transversal. This angle here will be the same angle here. Or this angle here, this one will be the same angle here. Very important to know. So that is the knowledge we are going to use here. You see, P, it is going to the center. This latitude will subtend this same angle at the center. Right? So the angle here, theta, or 65, the latitude is 65 south, 65 will be the same angle here, 65 at the center. So this point Q, we don't know where it is, will also subtend an angle X. This angle X here will be the same angle, it will be subtend here, X. So meaning that our difference is 65 plus X to give us point PQ. The angle subtended at the center is 65 plus X. Very important. Therefore, we know this one is on a great circle. How do we get that one? It is simply, for a great circle, it is simple. We know it is 60 times alpha. Not alpha, but theta times theta, because it is on a great circle. But we don't know that, but this is going to give us the distance, which is 5400 nautical miles. So how do we get the theta? We just divide by 60, divided by 60. This and this. So theta is going to be 90, right? So the angle difference theta is 90. The angle here is 90. But from here up to here, we know is 65. What will it be? X. So x plus 65, the answer is 90. Therefore, x is equal to 90 minus 65. And this one will give us 25 degrees north. So Q is 25 degrees north. You can also as well do it this way. We know that x plus 65 times 60, because this is the angle difference, will be 54. This one will give us x directly, 54. So this one we multiply, so we will have 60x plus 39 would be 5400. 60x will be 54, 900 minus 3900. So 60x will be 1500 divided by 60 divided by 60. So x is equal to 25 degrees. So because it went to the north, it's going to be 25 north. Therefore, Q is equal to, or Q is 25 degrees north, comma, they are on which latitude, or they are on the same longitude, which is 76 degrees west. Maisha ni magumu, lakini never give up.